Hello everyone, this is Professor Lee. So we're going to begin our lesson number 4 today, right? Okay, so what we are going to discuss today is about measure of center. Or sometimes some other reference book might say measures of central tendency. So in this lesson, in this class, what we're trying to do is this. We try to come up with one number, a single number, that best describe the entire data set. Right? Let me repeat that again. So what we're trying to do, we try to come up with a single number that best describe the entire data set. So what we are going to do, we're going to talk about the median, we're going to talk about the sigma notation, and we're going to talk about mean and trying to compare mean of two groups and compare median and the mean, and we're also going to talk about what's called mode. Right? So basically 3 different things: median, mean, mode. Right? Median, mean, mode. So what are those 3 things? Mean and median and mode, they are basically 3 different measure. You can think of it as a technique, 3 different technique to figure out a single number that best describe the entire data set. So, before we actually go on, let's think about it. Let's say you have like bunch of numbers, bunch of data, and you try to figure out a single number that best describe entire data set. And how would you do it? If you have a like bunch of numbers, let's say you have like 50 different data point numbers, and you try to come up with a single number that best describe that data set. Now, first one that's in here, it's called median. Median right here. So definition, median is some data value. Median of some data value is the 50 percentile. 50 percentile means what? 50 percentile simply means it's going to be right in the middle, right? Remember the percentile? So 50 percentile means 50% behind you, 50% above you. That means you are right in the middle. So what's a median? Median is the middle value. Middle. I mean, if you really think about it, that's not a bad number to present the entire data set, right? If you want to present like 50 different numbers, you line them up from small number to large number, then you pick the middle number. That's how you find the median. Now it says finding the median of a distribution. So to find the median of some data value, first list the observation from small to large, right? It says here. So, if you have like 50 different numbers, chances are it's going to be a mixed up number. So you have to rearrange it so that small number come first and the large number comes last. If the number of observation is odd, then median is going to be the middle observation. But if the number of observation is even, then median of the average, median is going to be average of the 2 observation. Now, what does that mean? Well, that means something like this. Let's say you have odd number of observations. Let's say, just for the convenience, let's say you have 1, 2, 3, 4, 5. Let's say you have this data set, right? And median is going to be the middle. I mean, the original data point could look like this. Could look like this. Let's say 2, 4, 1, 3, 5. Then you order it from small to large. Since there's a 5 different number, right? It says if the observation is odd, then you pick the middle one. This number right here. That's going to be median value, right? Simple. But let's say if the observation is even, if it's even, if it's even number like that, then what do? You pick the 2 middle observation and get the average of it. You pick the 2 middle number and get the average of it. So let's say you have another data set. Let's say 2, 1, 3, 6, 4, 5. Let's say you have this data set. Now what you're going to do, you're going to rearrange it. So you rearrange it like that. Now, oops, didn't show you this. So let's see, you have this is the original data set. Then you rearrange it from 1 through 6 like that. The middle number supposed to be right in the middle between these two. This is the case that we have even number of observation. But because it's an even number, what you do is just you take these 2 middle data point and add it up and divide by 2. So it'll be 7 divided by 2, which is what? 3.5. So 3.5 is going to be the median value. This is the median. This is the median value. All right? So if there is odd number like that, right? If you have odd number like that, the median is going to be the middle number, just simply the middle number. But if there's an even number like this, then median is going to be the 2 middle number and get the average of it, right? And that's going to be the median value. All right. So going back to this PowerPoint. Now let's talk about example comparing median of 2 distribution. Let's say we have this table. Now I want you to take time and look at this table. So, and try to figure out what this table is trying to summarize. So this first part, you have this Pacific states, and this one right here it has a mountain states. Oh, so this is a state in Pacific, and this is state that in the mountain. And this would be the minimum wage in dollar. Oh, so somewhere close here. It's not really close, but let's say Washington State, the minimum wage is quite high. That's interesting. I guess that's the highest. What's the lowest minimum wage? Well, lowest minimum wage is Mountain State, Wyoming. It's only $5.15. Right? So we have this table. What we're going to do, let's find the median minimum wage of Pacific states. And what does that mean in this situation? And the second question is find the minimum wage of mountain states and try to figure out what does that mean. So let's go back to this. So we're going to find the median of this, and we're going to find the median of this. So what do you think we should do first? Right? Try to figure out the median. Well, you have to list them again from small to large, right? So let's go back to this. So if you try to find the minimum wage for the Pacific states, then you rearrange it from small to large. Remember, we had 5 different data points. Rearrange it like it becomes like this. And we have 5 different, which is odd number of data point. So the median would be just right in the middle, right? Which is 8. So because there's a 5 observation, which is odd number, median is going to be the middle one, which is 8. So M for median, 8. And what does that mean? This means that about half of minimum wage are less than 50 and half of minimum wage are greater than, did I say 50? Half of the minimum wage is less than $8 and half of the minimum wage are greater than $8, right? Meaning 8 is in the middle. Now let's go to the mountain states. So we had 1, 2, 3, 4, 5, 6, 7, 8 different data point in the mountain states. So if we're going to rearrange it from smallest one. I remember it was a Wyoming, right? Was it? Yeah, Wyoming. And the highest was $8.25, which was what? Which was Nevada, right? Okay, so you rearrange it from small to large like that. Since there's a 8 different even number observation, which is even, right? Which is even. Then we get the average of the 2 middle observation, which is these 2 numbers in bold face. So you add them up and divide by 2, then you get $7.70. And what does that mean? Since $7.70 is the minimum wage, about half of the mountain states have more than $7.70 minimum wage, and half of the mountain states have less than $7.70 minimum wage, right? So that's the median. All right. Now let's talk about the sigma notation. So summation notation, also called sigma, let x1, x2, x3 all the way to xn be data value, and summation notation sigma xi stands for sum of the data value, which is sigma xi means from x1 all the way up to xn. So, let's go to this. Sigma notation is what? Sigma notation is basically that weird looking sign. This it's like M sideway type of notation. So why do we call sigma though? Well, sigma is actually a Greek alphabet, right? One of those Greek alphabet letters, and it stands for summing up. So when we have like sigma of x, that means you are adding all the x. That's what it means. You're adding all the x. In our PowerPoint, we had sigma of xi, and it was like x1, x2, all the way up to xn, right? Well, that's not that pretty, so 2 xn. So what does that really mean? That means if you have all these separate data point, you are summing them up, and you could have said, instead of writing like that, you could have wrote like this. But as you can see, this is long, and you have to write a lot of different symbols and the letters. But if you just write sigma x, or sometimes you put I, sometimes you don't put I even, that automatically means something like that, right? You adding up all that, right? So summation notation is this thing. And why in the middle of the median, why do we care about this sign? Well, it's only because in statistic they use this sign all the time, and they don't want to write all that, right? They don't want to write all that, so they rather just write this. Isn't that much simpler than this the right hand side of the equal sign, right? Writing all that compared to just writing this. Okay, so let's do some example of this sigma notation. Let xi, that's a small I, by the way. Let me change that actually. It's a small I, like, oops, not the whole thing. It's just the I. It's going to be the small I. Okay, so xi be the amount of foreign aid in billions of dollars listed in the ith row. So, for example, United States have 31.5 billion foreign aid, and countries like Germany has 14.1 billion dollars of foreign aid. So find all the x1, x2, x3 all the way up to x5. Why is it x5? Well, because we have these 5 different data points. That's why. Oops. Because we have 5 different data points. That's why we have up to x5. And find sigma xi, meaning what? Meaning you add all that, right? That's pretty straightforward, right? That's pretty simple, right? Okay, so let's go to the solution. So find all the x1 all the way to x5 is these numbers, right? Where do we get this number? We get this number from the table, right? 31.5, 17.9, 17.9 was from the Britain. So these are the x1 all the way to x5, and let's find the sigma of xi, meaning what? Well, simply just adding all that number, all those x's. If you add all that, it becomes 86.7. So total aid donated by the top 5 donor is 86.7 billion, right? That's what it is. That's sigma notation. Now let's talk about the arithmetic means. Sometimes they say it's arithmetic mean, sometimes they just say mean, right? And also known as average, the usual average, In normal conversation, when we say average is such and such, what does that mean? The average in that sense means you adding them up and divide by the total number of data points. Remember that summation sign right there, right? Same thing. You add all the x, and what's n? N being the number of data points. Right? So you use the summation sign to define what's called the mean. So, just quick, simple example. Let's say this, 6 different number represent the result from 6 different quiz. So first quiz was you got, let's say you got 8. In the second quiz you got 10. Next one is 8, and so forth. And if you add all that, then that becomes 51. So one measure of center is arithmetic mean, or simply the mean. And to find this mean, all you need to do, just add them up, which is what we did, 51, and divide that by number of data points. So we have 6 score result. So you divide that by 6, and you get 8.5. So the average, the usual average, but technically the mean, more specifically arithmetic mean, is 8.5, right? 8.5. Okay, any question? Well, if you have questions, please do contact me through email. Then I'll try to answer all the questions, right? Okay, so let's compare the mean and the median, right? What was the median? Median was the middle value. What was the mean? You add them up and divide by number of data points. That's basically mean. So let's consider this example. Let's say following data are the savings of 5 adults in thousands of dollars. So if you have like 2, that means you have 2,000. If you have 10, that means you have 10,000, 8,000, 7,000, and 14,000. How many people? 5 adults. So we have 1, 2, 3, 4, 5. 5 different data points. Find the mean saving. So because these results represent the saving. So how do you find the mean? Well, I think we forgot this. That should be you add them up and divide by the total number of data points. So there was a mistake here. If you add all that, if you add 2 plus 10 plus 8 plus 7 plus 14, then it's going to be 41. I wonder where we got this. Oh, I think it's that 5 should be here. So that 41 divided by 5, why 5? Because we have 5 different data points, right? 5 different data points, then it's going to be 8.2. So the average, but this number is in thousands of dollars. So we have $8,200, right? And that would be the mean. That would be the mean. And find the median. So what do you do when you have to find the median? Well, you list them up from small to large. I guess I can just get rid of this and thing. Right? So you list them up from small to large, and median was what? Median was the middle value, remember? Let's just give them enough space. So which one is the middle value? 8 is the middle value, right? So 8 is the middle value, and that 8 is going to be the median. So $8,000, right? So the mean was 8.2 million, $1,000, and the median is 8. Well, they're not that different, right? They're not that different, just that, only 0.2 difference. Now, let's consider third question, right? This is the same example. We have like 2, 10, 8, 7, 14. Suppose that the adult who had 14,000 in saving win 900,000 the lottery ticket, right? He or she won this $900,000. So that those who had $14,000, now we have $914,000. So I think this one there's a little bit of a mistake too. Now when we add, it's going to add up to here and divide by 5, right? So we have 2 plus 10 plus 8 plus 7 plus 1. You know what? That was right. That was $9,000 and 14. Right? So 9,014. That would be $941, and you divide that by 5, then you get this result, which is $188. Well, $188,200, right? So that means this is going to be the mean. Now, this is going to be what? This is going to be the mean. This is going to be the mean. Right. So because this one number was significantly larger than before, which will bump up the mean to 188.2. Let's go back to the previous one. What was the mean with the usual $14? That was 8.2. The mean was 8.2. Now what's the mean? 188.2, which is a lot. Big change. Why is it big change? Because that what used to be 14, right? What used to be 14 now become what? 914. If that's the case, find the mean saving of 5 adults after the lottery wins. Now, this time we're gonna figure out the median value. So you list them up. Now it's 914, not 14. You list them up and you pick the middle number. Well, again, this is like kind of a little bit difficult to see. So let me space it out. Then look at this. The middle value is still 8, even though this got really big. That's not really going to affect the middle number, the middle value. So what would you say? Would you say 188.2 describe the data set better than the median? Well, it depends what you want and depends how you interpret this, but I'll say because this is such an unusual case, right? This 914,000, that's such an unusual case. I would rather prefer median value to represent this entire data set. Just because one number is extremely big or small, that doesn't really bring down the entire average or bring up the entire average. I don't think that's a fair description, right? So depends on the data set and depends on the nature of what you want. It's different. right? So mean is sensitive to outlier, meaning what's outlier? Outlier is extremely big or extremely small number. That's outlier. So depends on the outlier. Mean is sensitive because it will affect, if there's an extremely big, extremely small number, it will definitely affect the entire data point. Median on the other end, however, extremely small or extremely big value doesn't really matter. It will not change the median because median is what? Median is the middle number. That's why. Okay, now let's talk about the distribution shape, right? Let's go back to our drawing board. Distribution shape is basically something like this. Let's say you have a graph and most of the data points is towards, say, the right side, right? The right side. Then what do we call this? We call this skewed. If it's the opposite, if it's most of the data is in the right side, this is what we call skewed left. That's interesting though, right? But that's how we call it. Most of the data points in the right side, then we call that skewed left. Now, in the same way, let's say data points looks like this. Most of the data points in the left side, this is called skewed right. This is called skewed right. Most of the data is towards the left. So it's like an opposite, right? Like I said. And, oops, I don't like that line. I don't like that line either. Let's say distribution shape is relatively bell shape, right in the middle. Then this is going to be symmetrical. Symmetrical or symmetric. Right? This is how we name those distribution. So if the distribution is skewed left, mean is usually less than the median. Well, this is the case. This is a skewed left case. What should be the mean? Mean should be somewhere here, say 12.7, and the median, the middle value, is usually a little bit towards the top part. So if you skew to the left, meaning the majority of the data points in the right side, then mean is less than the median. Right? That's what I say. Skew left, mean is usually less than the median. Skew left, mean is less than the median. Okay. If it's a symmetric, mean is approximately equal to median. Well, this is the case. It's a symmetric, the middle value is usually the mean value. Right? If it's symmetric. Now, if it's skewed right means what? Most of the data points in the left side. All right, so in this case, left side. If it's skewed right, then mean usually greater than the median. Mean is bigger than the median value. That's the relation between the skewedness and the mean and the median, right? Okay, mode. Mode is simple. Mode is basically most frequent or the greatest frequency. So it can be possible that you can have more than one mode, meaning there's a two number has same number of frequency, then we have two mode. Or let's say none of the data points got repeated. They all have a single data point. That means it's possible that there is no mode case. Okay, and this mode, we can find the mode when working with categorical value as well as numerical value. Right? It doesn't have to be the number. It could be the categorical value, which means the names, right? Names. Okay, for example, something like this. Let's consider this first data point. Now, look at this data point. Which one is the most frequent one? Well, you can see right away, 0 has the most occurrence. Then mode is going to be 0. Now let's say this is women's Olympic 100-meter run between 1984 and 2012. I guess United States has the most frequency. Then in that case, mode is going to be the United States. Remember, it doesn't have to be the numerical, right? Data point. It doesn't have to be the number, basically. All right, so that was relatively simple, right? We talked about 3 different measures that describe the entire data set in the best possible way. And we went for the median and the mean and the mode. And we talked about this, the distribution shape and all that, right? Okay, as for the homework, these first 3 questions, question 1 to 3, is just figuring out the median, mean, and the mode of the data points. And homework number 4, 5, and 6 is trying to figure out the distribution shape and whether the mean is less than, greater than, or approximately equal to the median, right? If you look back for our note, it won't be that difficult. You can just match it right away and try to explain why it becomes like that, right? For question 4, 5, and 6. All right, so that's all for lesson number 4. Okay, all right, bye bye. And just one more thing, just make sure that you do the homework and try to do before due date and put it in the mail, the Dropbox, right? And if you have any question, don't forget to email me, and I'll try to answer you back. Okay, bye bye.